If you ever use the garden hose, you already understand more about electricity than you think. Let's prove that. Because today we're talking about three words that you will hear a lot in the coming lessons: voltage, current, and resistance. Let's use the same garden hose comparison in order to understand these three concepts. So if you ever turned on the garden hose, you probably saw that water starts shooting out of the tube. However, based on how much it is on, the flow of water may go further. The further it goes indicates us that the pressure is higher. That means the water potential in the tube is higher. Right? Now, what happens if you put a cap on? If we cap this, the water stops flowing. However, the pressure in the tube, do you think, does it go away? If you guessed no, that's correct, because the hose is still on. It's just we capped the end. So this is what we call, when it comes to electricity, we call this voltage. Voltage is the potential energy or electrical pressure or push from the power source. When we take a look at a battery, let's say we take a look at this one, it says 9 volts. The pressure in this, or potential energy, is higher than in this battery, which is a 1.5, less than 2 volts. This is what we mean by voltage. Even though the current is not flowing yet because I haven't connected anything to it, the pressure is still there. This is voltage. As soon as I put the batteries into an equipment like this, then the current starts flowing. So now we can see that current compared to voltage is how many electrons are moving into a direction. So whereas voltage we measure between 2 points, in this case on the outside and inside, current we measure only at 1 point. At any point in time, how many of these moving electrons are here? Now, I kind of tried to help here because 2 points connected together is a V, whereas one cut in the hose is just an I. The symbol for voltage is V, and the symbol for current is I. In some cases in European literature, you might also see it as a U. So V or U is the same thing. It's actually the voltage, the pressure of electrons. When we talk about current, current is the rate at which the electrical charge flows past a specific point in the circuit. Here's an interesting fact. V comes from the name Alessandro Volta, who is credited for inventing the voltaic pile. However, I is for intensité, in French, as in intensity of current. For now, actually U, the letter U is for Unterschied, which means German difference. So voltage is difference between 2 points, is the difference of pressure from the inside of the tube to the outside. It is always measured between 2 points, whereas current is measured at a single point and means the intensity or the flow of electrons at 1 point. Now let's get into something really interesting that many adults don't know. And if you understand this next part, I promise electronics will be easy for you. So pay attention, but it's fun. You probably stepped on a garden hose once or made a kink in it. Do you know what happens in that case? Let's demonstrate it. So here's a garden hose, and if we do a kink in it. Look at that. What happens is that the pressure suddenly drops. So there would be water here, but there's less water coming through here, and only less water gets to this other side. So if we take a look at it between point A and point B, the pressure is different because there's a lot of water here, high pressure, but only water is seeping out here. However, the flow of water on both at point A and at point B is the same, because just like how when we capped the end, this is also a cap, and it's slowing down all this water behind it. So the rate or the speed of water here and here is the same. However, if I would poke a hole here, or I would poke a hole here, the pressure would be different. This would only go up this much, whereas here, because of the kink, it's before the kink, the pressure would shoot up all the way there. The flow of water is the same, however, the pressure between these 2 points are different. So now you can see what happened. This is what we call a resistor. In the case of electronics, we don't do kinks on wires, we introduce resistors. This is a resistor. This is how they usually look like. We will eventually learn the color codes and what do they mean, but it's essentially a different type of material introduced on the wire. Whereas a kink is a physical restriction, in the case of electricity, we have a different type of material introduced that slows down the traveling electrons. Resistance, the symbol of resistors is R. Now, of course, the electrons are not slowed down at all. The electrons are still as fast as they were. It is actually the rate or the current of the electrons is slowed down. So when we want to check for pressure, we will have a different pressure before, V1 for volt 1, and V2, a different pressure before and after the kink or resistor. The actual flow, or I, stays the same. Think about V. The pressure is trying to push the electrons. The resistor is trying to stop it. And I is the actual amount of electrons going through. Now let's recap everything real fast. Voltage, current, and resistance. If I take a 9-volt battery, such as this, and if I would connect the positive terminal to the negative terminal, electrons would be flowing all the way around. And the electric pressure, or volts, would be somewhere around 9 volts. Now, if I do the same thing, however, I introduce a resistor, such as this one, right here, what would happen? Still 9 volts of pressure is coming out from this end. However, as soon as it hits the resistance over here, it would drop. So by the time it comes back, depending on the resistor, it might be from 9 volts. And on the other side of the resistor, the pressure has dropped to perhaps 5 volts. So current doesn't drop. Instead, the current is restricted on the total amount. The current flowing through the entire circuit is restricted because of this resistor. The current entering the resistor is exactly the same as the current as exiting the resistor. Voltage drops, current is restricted across the entirety of the circuit. Now, as for assessment, try to play with that garden hose. See if you can put a kink on it and see the pressure drop. And if your dad asks anything, just say it's for science. Hey, if you enjoyed this lesson, consider joining our school community. There you will find more advanced courses and unit studies, with all lessons organized so you can track your progress. You will get downloadable practice sheets to complete after each lesson. Great proof of what you just learned. You will also be able to purchase kits and components right there, and if you ever get stuck, our help desk is ready to support you. Link in the description. See you there.